Right, been telling you with our cat falling out of the tree that the EP the cat has at the top of the tree that it loses equals the EK that it gains before it hits the ground here. And that works. You can use that, but only if we assume one thing. In the real world, as the cat falls, if you were to take actual measurements of the speed and what have you, you'll find that the EK here is less than the EP it had at the top. Some of that not all of the EP turns into the EK at the bottom there. Something happens along the way. And so as the cat's falling, in the real world, it's falling through air. So we have air resistance, don't we? And what the air resistance does, obviously it's going to slow the cat down slightly as it falls. And what it does, it converts, it changes some of the EK to another kind of energy, heat energy. Right? So not all of that, whatever your number of EP at the very top, the EK at the bottom will be a smaller number, and the difference is the heat energy that you've lost. So we should really say in the real world that the EP lost equals EK gained plus heat energy. And that total would still be the same. So that's why objects don't read the when you do your initial calculation like this, and you'll get a certain speed value at the bottom. In the real world, that speed is going to be less because the air resistance has converted some of the kinetic energy to heat energy.